Hello guys, and welcome back to another class of our course about the complete introduction to data science and Python. So in today's class we are still talking about some more statistical concepts, and this is what we will cover in this whole class. So we are going to talk about 4 very interesting statistical concepts that are very used in data science as well as in statistics in general, and that will be really interesting for you guys to know, once again, for the purpose of this course, but for your life in general as well. So let's jump right into it. So the first statistical concept that we are going to talk about would be the range. So basically, let's say you guys are in a data set and you want to know the range of the numbers that are in this data set. How exactly do you calculate the range of those numbers? So it's pretty simple. You take the highest number, so the max, minus the lowest number, which is the min, and this would give you the range of those numbers. So for example, in this case, as you can see, the max would be 8 and the min is, well, in this case 4, because this is where it starts. So the range would be 4. So basically, if we read the definition, it will be the difference between the max and the min in a data set. So it will allow us to know what is the spread in the data or the data set that we have. So basically the highest number that we have minus the lowest number that we have, and this would be our range. So in this example right here, the range will be 10. So the highest number is 12 and the lowest number would be 2. All right, the second thing that we are going to talk about would be quartiles, and basically this or percentiles. So basically those things will allow us to know, for example, who is the 10% best or the 10% worst of something, or it's just a measure in statistics. So basically this is a division of observations into 4 defined points. So you have the Q1, the Q2, the Q3, and as you can see right here we have a graph of quartiles. So basically the Q1 would be the 25th percentile. The Q2 is basically the median or the center, so basically this would be the center. And finally, the Q3 would be the 75th percentile. So if we take a basic example of some numbers, like here, for example, we have the 2, 4, 4, 5, 6, 7, 8. So in this case, the Q1 would be 4, so it would be the 25%. The median would be 5. The third, the Q3 would be 7, so the 75th percentile. And the max would be 8, the min would be 2. So once again, these are just basics. But let's say you have a data set of 100 numbers. In this case, it's pretty simple. The 25th percentile would simply be the 25th number. The 50th percentile or the median would be the 50th number. And the Q3 or 75th percentile would be the 75th number. So basically, it's just a division into percentages. So the first 10% would be the 10th percentile, so the 10th worst percentiles. All right, the next thing that we are going to talk about would be the standard deviation. And this is where it would be a bit more complicated because, well, the formulas are a bit more complicated. So first of all, what is the standard deviation? Basically, the standard deviation is the measure of variation or dispersion of a data set. It's something that is really used in finance as well. With the variation that we are going to talk about, the variance, that we are going to talk about a bit later in this class. So basically, the standard deviation works well with the data sets, and the way it's calculated, it could be calculated on a sample as well as on a population. So this is the formula basically, and what exactly does it mean? It's pretty simple. So we have the x right here. The x would be our number. So let's say, for example, we have a data set of 1, 2, 3, 4. So it will simply be 1 minus the mean of our data set. So in this case, it could be 1, 2, 3, 4. So the mean of 1, 2, 3, 4. All this at 2. So basically, you make the square feet. So you multiply it by itself. And you make the addition of everything. So it's going to be, for example, in this case, if we have a data set of 1, 2, 3, 4, it's going to be 1 minus the mean of our data set, everything multiplied by itself, plus 2 minus our mean multiplied by itself, plus 3 minus the mean multiplied by itself, plus 4 by it mean the minus 4 multiplied by itself, and everything divided by the number of numbers that we have. So if in our data set we have 4 numbers, it's gonna be 4 minus 1, which would be 3. For a population, it's a bit more different. Instead of making minus 1 at the end, so we will simply divide it by the number of numbers that we have. And at the end, it's gonna be the square feet of everything, the square root of everything. How to interpret the variance, the standard deviation, sorry. It's pretty simple. So basically, let's say you have a data set and you have a mean of 10. And in this mean of 10, you have a standard deviation of 2. So basically, if you add to your mean or your average 1 standard deviation, you have 68% of chances to be on target. If, for example, I don't know, you are, well, it's really used in the stock market. So let's say you want to predict your stock, it goes up or down by how much. So it's pretty simple. You will simply take your data, the data of the stock, and then you will simply calculate the standard deviation of this data. So let's say, for example, the mean or the average of this data would be 10 with a standard deviation of 1. So in this case, the price of your stock has 68% of chances to be 10 plus 1 or 10 minus 1. So it's going to be between $9 and $11 in the next, in the next X amount of times. So if you want to have 95% of chances to be right, it's going to be $10 plus 2 standard deviations. So in this case, it's going to be 2 multiplied by your standard deviation, or 10 minus 2 multiplied your standard deviation. So your stock would be between 8 and 12 in this case, because you have a stock that has an average of $10 and a standard deviation of 1. So it's pretty simple, and it's the same thing for 3 standard deviation. It's if you want to have 99.7% of chances to be on target, well, the price of your stock would be between $7 and $13. So those would be your extremes, or those would be like if you want to be sure to be 99.7%, having 99.7% of chances to be on target or hitting your stock price. You will add 3 standard deviation. Usually adding 3 standard deviation is not that much of a good thing, because it doesn't give you the opportunity to take risks, or your risk is really, really small. So the profit that you will make would be also really, really small. So this is for the standard deviation. The next thing that we are going to talk about would be the variance. So basically the variance is pretty much like the standard deviation. The only difference is that you will, basically the standard deviation is simply the square root of the variance. So basically the variance is simply the standard deviation of at 2. So standard deviation multiplied by 2. So basically how it works, it does pretty much the same thing as the standard deviation. It's a measure of spread in a certain data set. So basically it works pretty much the same way as the standard deviation. So usually people don't really use it. People use the standard deviation, but it's also really, really important to understand. So as I said, the method of calculation is the same thing as the standard deviation. You have 2 methods of calculation for a population or for a sample. The main difference is the n right here. So it would be all the numbers that we have, or if you calculate it for a sample, it will be all the numbers that we have minus 1. So if, for example, you have a data set of 10 numbers, it's going to be 10 minus 1. You will divide it by 10 minus 1 at the end. And if we compare both formulas, as you can see for this standard deviation, it's pretty much the same thing. The only difference is that you have a square root. That is the only difference. So basically the variance is simply the standard deviation multiplied by itself. So it's pretty much the same thing, with a difference because it's multiplied by itself, but at the end of the day, it gives us the same measure. It measures the spread of a certain data set. So this is really important to understand. So those were the things that we talked about in this class. So first of all, we talked about the range, which is simply the max minus the min. Then we talked about the quartiles which are percentiles as well. So you have the 25th, the median, and the 75th percentile, which are Q1, Q3, Q1, Q2, and Q3. So quartile 1, quartile 2, and quartile 3. Then we talked about the standard deviation, which is a measure of spread in a dataset. So measure of of spread. So you just to know what is the spread or how much something is volatile. So if we use it, for example, on a stock, it's a good way to know how much a stock is volatile and how much risk we are ready to take. And then we talked about the variance, which does pretty much the same thing as the standard deviation. But if you guys want to use something, for example, to predict stocks, once again, I really and highly suggest you to use the standard deviation, which is way better. So that's it for this class, guys, and see you all in our next class where we are still talking about statistics.